Hello, this is Professor Teft. In this project today, I'm going to walk you through an example set of Stata code in which I've set up basically a project that is going to be similar to what you're going to work on in your own capstone project. And I'll take you through the steps of downloading the project, opening it up, looking at setting up do files, running some of the code, and I'm going to walk you through each step of the way where I have commented out instructions on how to work with the code. So to get started, what I'm first going to do is go to my sections Lyceum page, and where I've posted this file or set of files here, example Stata project. I'm going to download that. And I'm going to put it in a directory I created. You can put it in whichever directory you want, and then you're going to unzip it from that directory. So I'm going to unzip files here. And as you can see, I'm going to delete the zip file here, so I just have the project files themselves. And what I've got here are a couple do files, and in an earlier class you learned about what do files are. They're basically batches of code that Stata can run, and which you can use to open and manipulate data sets, and then also conduct statistical analysis with them. So I have two basic files that I use. The first one that and this is a general pattern that I follow in a lot of my projects, and I think you'll find yourself doing as well because it's pretty convenient. The first file that I use is called construct analytical file. And what that does is it takes all the files that you've downloaded from your primary data sources plus any other data files you want to merge in, and it opens them up, pulls out the information you want, merges files together, appends files, manipulates some of the variables themselves, and constructs what we call an analytical file, and that's the file that you do your actual empirical analysis with. And I do that all in one separate do file here, because oftentimes it takes quite a while to run the code, and once it's all constructed, you want to be able to repeatedly run the actual analysis code while you're working on it. So then in a second file, I have my empirical analysis section. So let me show you, before I open up the analytical file, let me show you what data we're going to use. We have two data sets from BRFIS, the Behavioral Risk Factor Surveillance System, which is a CDC data set that tracks health risk information across the country. And notice I have 2008 and 2009, so I'm going to show you how to bring together two different data files that are the same survey but different years. And then I have a third file here, which is the unemployment rate by state and month between 1976 and 2013. And I'm going to show you a couple things with that. One is how to reformulate that into a format that will be easy to merge into the BRFIS files, and then also do the actual merging itself. So these are the three raw data files that I've downloaded. And let's open up the do files here, starting with the construct analytical file. You can either open it in Stata, like Christine discussed last week, or you can just right-click and press edit like that. So here's the data file or the Stata do file that I already constructed. And you'll notice that I have in green here lots of comments, and I heavily commented this for your purposes so you can see exactly what I'm doing. You don't have to do this in your own file necessarily, but although your instructor may ask you to do so that they know how to read it as well. So first of all, what we do here is a couple of introductory statements, clearing all data sets out of memory, setting more off, which allows you to just run the file, and then all the code will just spin out. You don't have to keep pressing spacebar to scroll through things. So that's just sort of housekeeping. The next line here is change directory. So we want to change the directory to wherever we decided to save that project. So you'll notice here, if I copy and paste this directory and change it, then I can save it. Now it will have the correct directory when we're working with this. Notice I put the raw data files in a separate directory within this working directory, this temp working directory. So you need to make sure you maintain the same directory structure for your own project, and then you can reference it, as I'll show you throughout the do file. Okay, so the next thing is we are going to open a log file, and Christine introduced how log files work. One thing I do is, because I repeatedly run these things and get lots of errors, I first try to close the log, and I capture that command. What that means is that if Stata tries to close the log and there's an error because there's no log to close, it just ignores it and then moves on. This is just a little time-saving device that I have. You don't even really need to have it in your file. Then I open the log file itself right here, and I'm going to call it construct analytical file, and it will automatically generate an extension called .log, and then I'm going to put it in a text format so that I can easily open it in any text editor. So you'll be able to do that. And what the log file again is going to do is it's going to save all the results from actually running the do file, which will help when you go back and look through, and you can see what actually happened. Next thing I'm going to do is make a new directory if it doesn't yet already exist. I'm going to call it constructed data here, and what that is going to do is put the analytical file and other constructed data sets that are generated from this code into that directory to keep it separate from the raw data, as I called the folder where I'm adding new data sets. Okay, so then the first thing here that I'm doing, I'm going to show you a couple of programming tools as well, which you may or may not use. You don't necessarily need to use, but I find very, very helpful. What I'm first doing is defining a couple of just constants here. I think they're called macros in Stata. But what they are just basically declared variables that are stored by the program. So I'm telling it whenever it sees the word first survey year, I want that to be 2008, and last survey year I want that to be 2009. And what that's doing is the reason why I put it up here is because I'm going to use it multiple times below, and I can just change. And instead of going through and finding all the places where I use 2008 in the below code, I can just change it in one place and then automatically updates the rest of the code. That's just a simple programming declaration, as we call it. All right. So now that I know I'm going to be using these 2 years, I'm going to move down to look at this loop, which is, I'll scroll down quickly here and highlight it for you. It's pretty big. This is all one big chunk of code, as you can see. And I'm not going to go through all of it today, but I'll give you a general description so you can build your own code, because you'll probably be using different data sets, and you may not do an extensive build as I'm doing here. But what this is a whole section of code over which I'm looping. And the reason why I'm looping over it is because I want to do exactly the same, or nearly the same, operations with both 2008 and 2009. And so you can see if I'm looping, this for command says for all the values between the first survey year, which is here, and the last survey year, which is here. So in other words, 2008 and 2009, I'm going to run all these commands. And then I'm going to just put these variable names in when it needs to know which one to use. And actually the variable names will be assigned to I, and so you can first see that here. It's going to open up when it says use raw data / cdbrfs i.dta. Then it's going to open that data file, and if you remember back here, that's the name of it there. So the first thing we do in the loop is we open the data file. Then I'm taking a random sample of the observations in that data file, because in order to speed things up, basically. And sometimes, ideally, you won't do that with your own data sets. You'll use your full data sets. And let's open this up. I can double click on a Stata data file, just like this, and it will open a new window, and then I can actually browse and look at it. Use the data editor browse, and then you can see all the different variables in here. So they're quite large files, you can see. And if we scroll down all the way, we can see that in these particular files there are 400 15,000 observations or so for 2008. So that's a really large amount of data, and so that's part of the reason why I'm taking the sample size. All right, so let me close out of that, go back to the do file. All right, the next thing we're going to do is do lots of different data variable manipulation. This is all this stuff in here, all this code going basically down almost to the end of the for loop. And I won't go through all of that, but I'll go through a little bit of it. And these are going to be commands that Christine introduced to you, and you can look back in the Bates Stata library guide for help on working with it, whatever variables you're interested in. And you're basically changing the data set, the underlying raw data set, into a format that will be convenient for doing statistical analysis. So for example, I start off by converting the interview day, month, and year from string into a numeric format because I'm going to use those interview dates heavily, that information, in my analysis. And that dstring command just converts it right there. By the way, as we go along, because I'm going to start moving quickly through the code, you should at any time be able to open up a new Stata window and then search for help on any given command, in addition to looking for it in the states in the Bates Stata library guide. So if I open up a new, let's suppose I wanted to learn how dstring works, how that command works better, I can open up a new Stata window and say help dstring, type that in, and then I get a whole built-in help file that's built into the Stata program, and it comes with lots of information. So first about the syntax, which is how you type the command in, and then down below it there's a brief description, and then it talks about what all the different options mean, which you can type in. One of the most important and really helpful pieces of information in the help files are just examples. So you can just go through and say, you can actually run this command web use, and it will it'll import a data set that's out on the web. You can just run this right in Stata, and then you can run these commands and see how it works. And that quickly helps you to learn what's going on with these different commands. And you can see they have several examples. One more thing that's also useful is if you click on the title right here, I clicked on dstring, it opens up a PDF documentation file, which is the full documentation that's included with Stata. And a lot of this stuff is similar, but if you scroll down towards the bottom, remarks and examples are expanded. So you have more information listed in the PDF files than you do in the built-in help commands in Stata. So you can see there's all kinds of stuff here. And they have references where you can look things up more. There's quite a bit of information. And also they also give you hints about what other commands you might be interested in. Okay, so let's close that PDF file. I'm going to close this help file. I'm going to close the Stata window where I looked up the help file and get back to my code. All right, so dstring, I've converted interview dates to years, or to numeric variables. I'm also going to convert two-digit years into four-digit years when necessary. And here I use an if command. And if commands are just a logical statement saying if this expression is true, then do whatever follows. Then I'm going to recode month into quarters. So you can look up how that command works if you need to. I'm going to go down through, and now one thing that happens when you use this loop structure is that sometimes there are exceptions. So like I said, it's really convenient to be able to do exactly the same long list of code for both 2008 and 2009, but sometimes things are different. So for example, the 2009 state variable name is different. It's a underscore state, whereas in 2008 it's underscore state. And so what I'm doing here is I'm just changing the 2009 state variable name to be the same as the 2008 state variable name, so that when I append these files at the end, they will be consistent. Okay, let's skip down here. A couple things. This mvdecode command decodes missing variables, so it automatically looks at the age variable and finds those numbers 7 and 9, and converts those into missing values, which again is a period in Stata. In this particular data set, Burfus, they only ask their only respondents are the respondents are only aged 18 and up, and so 7 and 9 are just representing missing values in this case. And you can look in the codebook for Burfus for more information about that. I'm generating a couple of dummy or indicator variables in order to indicate male or female. And so in this case, there's a separate variable called sex, and when sex is equal to 1, that indicates a man. When sex is equal to 2, that indicates a woman. But when we're running regressions, we need it to be in a 1 and 0 format. That's how dummy variables are set up, and you likely learned about this in econometrics. So what I do is I generate male is equal to the case where sex is equal to 1, and what this will do is it'll return a 1 when sex is equal to 1. It'll return a 0 when sex is not equal to 1. But one important thing to note is that I have to be careful and make sure that I don't base the construction of this variable on missing variables as well. Because if I did not include this qualifier, if sex is not equal to missing, then what it would do is if sex was not equal to 1, but it was missing, it would assign male to be 0. So, which is not true because we actually don't know what the sex is of that observation. So it's important to remember to remember to make sure that you're taking care of missing variables appropriately. Okay, moving down past that, we're decoding some other variables, in this case self-reported health, recoding some variables, here renaming variables again to make them consistent between 2008 and 2009. Scrolling further down, we're doing the same with some race and ethnicity variables, where we're recoding some of the Burfus data sets, and then again creating dummy or indicator variables in this case, which indicate white race, black race, and Hispanic ethnicity. And I'm again just using some of the information in the codebook about what are missing and what are true values. In this case, here's a sort of new example. I'm saying generate ethnicity Hispanic is equal to when this Hispanic 2 is equal to this Hispanic 2 variable is equal to 1. If Hispanic, and here's the new piece, if Hispanic 2 is less than 7, what I've done is I've just said, oh well, all the values that are 7 or higher actually indicate missing variables. So if I'm only creating this indicator variable for those observations where this is true, then all the other observations where Hispanic 2 is greater than 7, greater than or equal to 7, then it will just set all of those to missing. So again, you have to be careful about missing variables. And I'm doing the same here for marital status. So I'm creating a dummy variable for whether somebody's married, and also education level. So education, whether somebody's a high school graduate, has some college experience, and a college graduate. Okay. Here I'm setting missing values equal to periods for employment, some employment variables, and then I'm also doing the similar thing for income variables here. Now down here there's a few sections of code, starting here with this statement, generate the alcohol variables, and then going all the way through down through smoking, where I have a tremendous amount of, it looks sort of tremendous, amount of code. And this, so for example, this block here is all the alcohol variables that are used in, that are included in Burfus. Or I shouldn't say all of them, but they're all of the variables that I need, and then I'm converting them into formats that I want, according to the hypotheses or research questions that I have. So you can see, for example, this first block I'm generating any alcohol, and what this means is in the past 30 days. So there are questions from which I can gather information about whether a respondent drank any alcohol in the past 30 days. And I first generate it as an empty variable, set it all to missing, and then depending on the years, the survey years that I'm using, and notice I left a bunch of these survey years in here, even though we're only working with 2008 and 2009, Um, and this whole block represents all of my knowledge about all the data files from Burfus with respect to these drinking variables. And you can see this is a good illustration about how you need to be careful also about how variable names or variables change across years. So if you're using a couple years of the same data set, don't assume that the variables that you're interested in are going to be the same in both years. You have to check and go through and make sure that whatever you're including in your regressions, you understand the variable descriptions for any given year. So I included all these alcohol variables. I also included cigarette variables, so a lot of information. I'm not going to go through all that stuff, but it's all using similar processes to what has already been described. I also included some exercise variables, whether somebody reports having exercised at all in the past 30 days, and some information on whether during their last car ride, or excuse me, not during their last car ride, but on average, whether somebody uses a seatbelt always, frequently, sometimes, never, those kinds of questions. And again, I won't go through all the details of these because it will depend the logic that you use will depend on whatever data sets you end up using for your project. Okay, so at this stage, I've gone through the loop for one of the years. Suppose we just started with 2008. The code is scrolled all the way down through here, created all these different variables. Now I get to this section here where I keep only those variables which I really ultimately want. So if you recall, when I opened up the data file itself, there was a large number of variables, but I really only need a handful of them for my analysis, and so I keep all of these that I need. Some of which are built in to the data file, and many of others are ones that I constructed along the way. And then this is going to form the core set of variables for my analytical file. This last set of code here simply saves the file and or appends it. So what I am saying here is if the loop is on the survey year, which is after the first survey year, then append it to this file that I'm saving called the analytical file. And that would only happen if I had already saved that file through the first iteration of the loop. And that's going to happen, that first iteration is going to happen here. It's going to skip that if statement above it during 2008. It's just going to save this file. And then when it goes back through 2009, it's going to find that file and append it. In other words, when you append, the append command here tells Stata to take two data sets and just stack them one on top of the other. So in other words, keep the same variables, but add observations to the existing data set. That's what append does, and I'm sure many of you will need to use that command. Okay, next, after we've looped through and we've constructed the basic analytical file, as you can see it's here called analytical file, we're going to continue on and flesh that out. So this next set of code, which is looks like down these two blocks here, I'm first going to, my goal here is to merge in unemployment rates. So I have a data set full of respondents who answer questions about risk, health risks and behaviors. And now what I want to do is I'm going to ultimately correlate it with unemployment rates in my analysis. So for example, what we do here is we first run this command called preserve. So what that's going to do is in memory we have analytical file, this data set up here where I've combined Burfus data sets. That's in our memory. We're going to preserve that. It's sort of like saving it temporarily while I go do something else, and then we'll come back to it in a bit. So we're saving that temporarily, and then we're going to open up another data file here, which I saved in raw data, which is the local area unemployment statistics, state by month, unadjusted information between 1976 and 2013, and that's in a wide format. So let me show you what I mean by that. If we open it up and then browse, here you can see we have these state codes, and these state codes, each number represents a different state, and these are called FIPS codes, so you can look those up online. And for each state and year, we have a list of information. And the first, you can see the variable names up here. You can see there's unemployment rate 1, unemployment 1, employment 1, labor force 1. And then there's unemployment rate 2, unemployment 2, employment 2, and labor force 2. What those numbers mean at the end of those variable names are the months. So you can see we can scroll all the way over, and then we have 12 at the end. So we have a different variable for each kind of information, for example, the unemployment rate and month. But what we really need is we need to be able to have a separate row or a separate observation for each year and month. So we essentially need to restructure the format of this file so that we can merge it directly into the Burfus data file. And the reason why is because each Burfus observation is a respondent who was interviewed in a particular year and a particular month. Also a particular day, but we don't need that information for this merge. And so because each person was interviewed at a particular time, we need to be able to merge directly in using both of those variable names. All right, so we need to transform this file and the way that's going to work is it's going to use that file, open it up, and then reshape it in a long format. And that's going to be consistent with the data set that we're using. And then we're going to save that as its own file right here. And then we'll be able to merge it in after we restore the original data set. Okay, so far I've not actually been running any code, and the reason why I haven't done that yet is because for the most part we were working with variables and commands that you learned in the last section. But now I'm going to start actually running the code, and so you can see what's going on. So remember we saw that data file of unemployment rates in the wide format. Now I'm going to run everything up to this point so you can see what happens when you convert it. Now the other thing is that you can run code. You can run code using blocks. You can either blocks of selection. So in other words, if I select a block of code, you can run that block, or you can just not have anything selected and then click run, or in this case execute is actually the command that we want to use. The execute command, if you don't select any information, will just run the whole data file. So what I'm going to do is I'm going to select everything from the top down to the bottom of the for loop and run that first. So I'm going to say click do. We'll go look at a results file, and you can see it's running it, so it's going through all those things. And it did all of that data manipulation that I talked about, and it saved this analytical file. And remember, now you can see the list of variables are all these variables that I told it to create. We can look at it, and you can see it's if we scroll across right to left, there are not as many variables as there were in the original data set. And also because I took a 20% random sample and then combined the 2 years, there's fewer observations than there were before, so only 170,000 now. The other thing is you can see that I've appended the two files together because we have this year variable for 2009, and then if you scroll down, keep going, and then there are bunches for 2008. So I've actually successfully appended the two files together. You can also check this by saying tab year, and then you can see in fact that there are 2008, 2009, and actually a handful of 2010. Those 2010s come in because people in the 2009 wave were actually happen to be interviewed at the very beginning of December. But that's okay. It doesn't really matter if those are in for now. Okay, so we've actually constructed everything up through this for loop, and you can go back and run separate pieces of code step by step yourself, and you can see how everything is constructed in that way. But I did want to show you how these other commands down below work. So the first thing I'm going to do is reshape that file that I told you about to be a long format. So that code that I just ran preserved the data set in memory, and then reshaped the unemployment rate file to be long, so it took all of those month variables and then compressed them, And let me show you where that put that. So put it in the constructed data folder, and here's this new file it created. And if we open it up, now you see there's a separate row for year and month, whereas before there's only a single row for each state and year, and we had all the different months in the variable names. Now it's separated out by month, and you can see there are only now 4 variables of information left. The one we're going to be interested in is unemployment rate here. Okay, so we've done that. Now what we're going to do is do the actual merge. So this is going to be yet another command. This merge command is going to be yet another command that you're going to use often, where you're going to connect 2 data sets to bring new information in. So here what I'm doing before I run it, I'll just explain. I'm merging the Burfast data files, which are now back in memory, have many observations because they're all people who are being interviewed. Many observations for each state and year. And that's what this M stands for. And then I'm going to merge in a data file which has unemployment rates, but just a single piece of information for each state and year and month. So you can see these are the 3 merge variables. So for each state and year and month, I have lots of people, but just one unemployment rate. And so you have to tell Stata how that works. And then I'm going to merge, because I have the Burfast data in memory, I'm going to merge in this constructed data of unemployment rates that I just made. I'm going to tell it what variables to keep, what observations to keep. So I'm going to keep everything in my data set in memory, which is all the Burfast data, because I don't want to drop any of that. But I'm only going to merge in unemployment rates when I can match to the other data set. Otherwise, I just leave it blank. And then this keep using option tells Stata which variables to include. In this case, I want to keep the unemployment rate. Okay. Then I'm going to drop those observations where the unemployment rate wasn't assigned, and here it's going to be in this case it's going to be respondents from U.S. territories outside of the 50 states. I'm going to drop those respondents because what I'm really interested in my research question, and again this is just a simplified smaller data file than I've used in previous projects, but it's based on some, and so I need the unemployment rate because that's what I am interested in doing for my research question. So I'm going to drop those respondents, and then I'm also going to drop the variable itself, which this underscore merge variable was created by the merge command. And then I'm going to rename these variables here into variables that I'll use in my analysis. Okay, so let's see how a merge works. We'll run this. Okay, so it renamed these variables, then it ran the merge, noting that almost all of the observations matched. There are a handful that didn't match, and those are the ones that were from the U.S. territories, not states. And then we drop that merge variable name, and then rename the variables. And lastly, before we're done constructing our analytical file, I'm going to create a whole bunch of dummy variables. So this is a really useful command here, xi, right here. Xi is a useful command because what it does is it creates dummy variables for all of the different values in each of these variables. So for example, employ has several different employment statuses, and I want to just control for all these different employment statuses, but they're all labeled as 1, 2, 3, 4, 5, for example, which is meaningless in a regression model, but it would be nice to control for all of those different statuses separately as separate dummy variables in my regression models. So this will build out a whole bunch of different dummy variables, one for each value that's listed in employ, and it'll do the same for income. And then for my state and year and month fixed effects models, I think I'm going to end up just using year in this case. We're going to build out dummy variables for each value of each of those. So this will create a whole bunch of new dummy variables. So let's do that. And you can see it's building those out. And if we scroll over, it starts here. Build this underscore capital I employ underscore 2. So these are all the different values of employ, all the different values of income 2. all the months, all the states. Oh, there's a couple years in there too over here, 2009, 2010, and then all the states out to here. So lots of dummy variables, but those are going to be very useful in our regression model. Okay. And then finally, we'll save this final analytical file that's been created by manipulating variables in Burifice, merging in new variables from another data source, creating a bunch of dummy variables that we're going to use in the analysis, and then saving it all. And then we're going to close the log file. So without highlighting anything, I'm going to just run the whole data file like this. It's going to do it all at once. Now, this is the beauty of the do files, which is that you just save all of your code in there, you do it once, and then it creates an entirely new file all ready to go for your analysis. And here it is in the constructed data set. It's called analytical file. So that's going to be the file that we use for our empirical work. Okay, let's move on to our next do file. So we can open it here in the same window. You actually can either go to the open command or you can just drag it in. So I'll go up here. So this is going to, now we're going to conduct our empirical analysis. So I can move it over, drag it over into this window, and open it up. Okay. So a whole other large do file, and let's work through it. So first we're going to again do our housekeeping commands at the top. As you know, we're going to change directory to whatever directory we're interested in, and I need to do that. So don't forget to edit that. So I'll copy and paste that in here. Otherwise, you'll get an error that tells you can't find that file, and then you'll know that you need to change the directory. Open up a new log file. In this case, conduct empirical analysis is what I'm going to call it, the same as the title of my... I usually title my log files the same as the title of my do files, just to keep them paired up. I'm going to capture and make a directory called results. So the results of our empirical analysis can be put in there. And then we're going to use or open our analytical file that we just created. Okay, so now our file's open. We're going to do several different things. One thing I'm going to do here is I'm going to create what are called lists. And lists, actually in this case, they're going to be simple strings, so it's even easier than a full list. And the string is I'm just going to write in the name of all the variables that I'm interested in that are part of a cluster. So in this case, here are all my demographic controls: age, male, race, ethnicity, education level, and marital status. And then I'm going to put them into one string called demographic controls, or demog controls. Then I'm going to have all my income controls. Turns out I just have one collection of dummy variables. So when I put this little star here, that means all of the created income to dummy variables that I created at the end of my last file. Those are all my income controls. All my employment controls is going to be this list of all the employment dummy variables. My time controls I'm going to control for month and year. So I have all these. This is what we call a month and year, and then later state fixed effects models. So we have all of these fixed effects that will affect the outcome separately for each of those time periods and geographies. So our geographic controls here are each state. So this again, the star will pick up all of the different states. So there'll be a dummy variable for each state. And then, lastly, I'm going to make one big long string which combines all my controls together. So you don't need to make these lists like this, but I find it easier to read the regression command code below when I have these lists, because I don't have to type in the big huge list each time. Alright, the first thing we'll do in this empirical analysis is summarize the data. When we summarize it, one thing that's good to do in any empirical analysis is not only have an analytical file, but make sure you can identify all those observations where nothing is missing. And so I create this variable called nothing missing, and then here I loop through all the control variables that I'm interested in, and then I set to 0. I set this nothing missing variable to 0 when I find an observation where something is missing. So what I'm left with at the end of this big loop is only those people, those respondents, who have information for all of the variables that I'm interested in. And that's what I'm going to summarize ultimately. So I'm going to count how many people there are with nothing missing in their row or their observation, and then I'm going to summarize all that information right here in this command. So let's do all of that so far. Let's execute that. And you can see it went quite fast. And the last thing that was produced here is a summary or a list of all of the variables that I'm going to be using in my analysis, with the exception of all the month, year, and state fixed effects. We're not really looking at that. But this output is useful. You can actually just directly copy and paste it into an Excel spreadsheet, and it will tell you for each variable, for example, age or whether somebody exercises. It tells you the number of observations for which it's not missing. Some of these, by the way, I didn't include in my nothing missing. Looks like up to here in my nothing missing command, because these are outcome variables, and outcome variables you don't need to worry about as much, at least in the way I do my analysis. But in any case, you'll be able to see the mean, standard deviation, minimum, and maximum values of all of the different variables. And it's good to look through these and make sure they seem sensible. For example, age is between 18 and 99. That makes sense. 99 happens to be a top-coded value. So, if somebody's actually 101, they'll be coded as 99. But in our analysis, that's not going to be too big a deal, because we have very few people who are that old in the Burfus data set. And then you can look at other things. For example, proportion of the sample that's married, 57% or 0.57. That seems reasonable. If you had something like 99.9% married, then you would be concerned. Also, you would expect for dummy variables your min and max would be 0 and 1. If you had a different min and max, you also should be concerned. So this is something that you should definitely do before you run any regressions or do anything else to sort of give you a sense for what's going on. Okay. Now, after the summarizing the data, I decided to create an example graph for you. So here, what I've done is I'm preserving the data in memory. Again, just sort of saving it temporarily while I manipulate the data. Then what I want to do is show you a graph of the unemployment rate by month. And what I mean by unemployment rate by month here is I want to collapse the data all down into a format where I just have, for each month, I just have one value, which is the average unemployment rate across all respondents in the data set, and if we use weights, it'll give us a nationally representative estimate, or a national representative mean, I should say, of the unemployment rate. And and then I want to show in a graph what that unemployment rate is for each month in the data. I'm going to do a few different things. One is I'm going to create a year-month variable, which is basically integers going across years. So it's not 2008 month 1, but it's something like 10,000, 10,001, 10,002, and it allows you to create a full graph across years, as you'll see. I'm going to collapse the data set. Now this collapse command is going to be handy for you in many cases. And the collapse command, what that does is it takes the entire data set you have, it's going to collapse it by whatever variables you tell it to out in this by option, and it's going to basically produce rows that a single row for each year month. So it's going to be a much smaller data set at the end. Instead of 170,000 observations, we're going to have a handful. And what it's going to do when it collapses it, it's going to take the mean unemployment rate across all of those observations for each year month, and it's going to weight it using a weighted estimate option using this variable called final weight. And weighting is something that is often used when calculating nationally representative mean estimates or other estimates. It's sometimes used in regression models. I don't often require my students to use them in regression models, but it depends on your instructor. So some instructors might require that. Okay, so we're going to collapse the data. Now that it's in this format, we're going to reformat year month so it looks nice when we put it on a graph. And then we're going to do a two-way line graph. So this graph two-way line command actually produces a graph using Stata's Stata's graphing capabilities. And the graphing capabilities in Stata are quite extensive. I mean, you can create all kinds of different graphs using all sorts of different options. And so I encourage you to take a look at that, perhaps instead of building graphs in Excel. Um, Again, it's just a learning process where you can work your way through the help documentation by typing in, for example, help graph two-way or something like that in the Stata command box. And then I'm going to save the graph in a file, and then I'm going to restore the micro level data to get back to the micro level data. So let's do this, and I'm actually going to run the do file up to this point. Cancel that. I'm going to run it up to this point where we can see what the data set actually looks like after you collapse it. So that's run. Notice I've collapsed the data set. Oh, right. But because we're doing a preserve, it's not going to let us look at it. So what I'm going to do is I'm going to comment out the preserve. And in this case, if you were to run the file, it would not preserve the original data, and so that would actually be cleared out of memory. But that's okay. We'll restore that. We'll take that comment out in a minute. So we're collapsing this, and now you can see this is what the data set consists of: a year month, which in this case extends from 576 out to 601. And an average unemployment rate by state. And that's what we're going to graph. So let's go back to our code, take out this comment, save it, and then I'm going to run everything up to this point so it'll actually create the graph so you can see it. Okay, and there's the graph. So you can see it goes from 2008 month 1, so that's what this 2008 M1 means, and then progresses along across the months all the way out to 2010 month 1. And one thing you'll notice is that I chose these years because they're right in the middle of the financial crisis, or they span the financial crisis and the beginning of the recession, and actually most of the recession during the Great Recession period. So our unemployment rate was pretty low down here, around 5, in between 5 and 6, and then just marched up steadily until 2009, and then sort of remained flat up here. Okay, so now we've summarized the data, we've created a graph. Now I'm going to close out this graph. And we basically have one more set of things to do, and that's run regressions. And I created a whole bunch of different kinds of regressions here, several different kinds. One is here OLS, linear regression models. Here's probit. Here are ordered probit. And here are instrumental variables regression models. And I am going to probably just cover the regression model section here, or the OLS linear regression model section here, and then let you look at the others as you wish. And of course, depending on what models you end up actually using in your analysis. Many of you will not use all of these, but will only use some of them. So what we're going to do is look at just linear OLS regression models in Stata, and a couple of just handy tools that I use for outputting the information, as well as running several different regression models. So before I go through the details, let's just skip straight to this line, which is the actual regression command. So reg here is short for regression, or regress, I'm sorry. It's short for regress. That's the command in Stata that runs the regression. This variable right here is going to be dv, stands for dependent variable. So there are going to be several different dependent variables that are going to be inserted in here. This is the unemployment rate, state level unemployment rate. And then here's our list of all controls that we formed way up top. And then I'm going to cluster the standard errors by state. So that's just a recommended standard error construction based on the fact that we are using presumably sort of a policy experiment type setup which varies across year and state. This is just one way that you might set up your standard errors depending on your project, and you would need to talk to your instructor about how you do that. Okay, so that's it. That's the simple bit. That's the basic regression command in the middle that we're going to run. Now, what's happening is there are some other things going on around it. First, what's happening, and I'm going to sort of build out around it. Again, I told you we're inserting those all controls variables each time we run a regression, and that all controls comes from above. This dependent variable is going to come from the for loop that's right above it, right here, where it says for each dv in this list, and then it's saying loop over all the dependent variables of interest for the linear model. So this list here is the number of times a person consumed alcohol in the quantity of at least 5 drinks. So in other words, the number of times that somebody binge drank in the past 30 days. Here's a measure of someone's physical health on a scale of 1 to 5. We might not necessarily want to use a linear model for that. We might want to use an ordered probit model, which I do use below. Excuse me, actually the physical health, that's true for general health. So the general health is on a scale of 1 to 5. The physical health variable is actually a question that asks respondents how many days of the last 30 days have you felt to be in poor physical health? And the same question for mental health. How many days out of the last 30 have you felt poor mental health? And so these are just measures, broad measures of physical health and mental health. Again, we will model these as linear, but they might be better modeled as ordered probits or something else. And what it's going to do is it's going to loop over all those different dependent variables, and it's going to run a separate regression for each of those. So we're going to get an output just with this for loop of 1, 2, 3, 4 different regression outputs. Now the last thing is there's a command called outreg2. And outreg2 is a command that may not necessarily be installed on your computer, but you can do it. And to do that, you would run the command net search outreg2, and it would go out and find it, and then you'd scroll through until you found it. Outreg2 right here. So then you could click on that, then it opens up this window, and then you could click here to install. Pretty sure it's already installed on this computer, so I'm not going to click on this. But you would do that. It would just run an installation, then you'd be all set, and then you can include it in your Stata code. All right, so let's go back here. Anyway, what outreg2 does is it takes regression output and it dumps it into a file that is basically an Excel file. So that's where this Excel command option comes in. It's really an it's an XML file, which is a kind of file format that can be opened in Excel. So the great thing about this command, this outreg2 command, is if you run it after regression, it takes your results, puts it in this file that I'm calling OLS results in this case, and then puts it in a format that's easily copyable and pastable into Excel or Word, and then you just easily have tables built for you. And what's going on is I'm dropping some of the fixed effects, so those don't get all dumped into the Excel files, but it's keeping all of the most important variables. And then up here, I'm just erasing the files, those outreg files that I had already created. I'm erasing them so that I can build them again. So let's run all of this stuff up until this first set of regressions. Go to do, and it built the graph again. That's fine. Now we'll go to the output, and you can see it ran. Let's see. Let's go up to the top. It ran 4 regression models. So here, remember, it used each of these dependent variables separately. That's the dependent variable in this regression output. Then here's the independent variable of interest. If this is the research question that we want to see how the unemployment rate varies with the number of times that people binge drank. And then here are several different control variables. And here you can see, although the unemployment rate wasn't significantly correlated with the number of times somebody binge drank, a lot of these demographic variables were. So in fact, the older you get, this is highly significant, a p-value of 0. The older you get, the fewer times you binge drink. If you're male, you're more likely to binge drink. There's a positive coefficient here by quite a bit. excuse me, that's not likelihood. That's the number of days in the last 30 in which you binge drank. And then so on and so forth with these other control variables. And then here are the set of income controls, set of employment controls, and then all the fixed effects. See all these state dummy variables, which the coefficients themselves are fairly meaningless at this point given the model that we've set up. And then we also have month and year controls. So lots of different controls. And then you can see there's output for physical health. Again, the independent variable of interest is uncorrelated for that measure. We have mental health, uncorrelated for that measure, and then general health also uncorrelated for that measure. So the model that we've set up tends to have a fairly weak association, especially in particular for those years that we're interested in. And this is actually consistent with a paper that has recently been published in Health Economics, which is questioning the relationship between the unemployment rate and self-reported health behaviors or health statuses in recent years compared to previous years. So this is sort of a very simplified basic model which kind of somewhat reproduces on a paper in Health Economics that was recently published. Okay, so we have these 4 different regression outputs, and then like I said, we're storing all of our results in this folder called results, and this XML file opens up in Excel. So let me open up this XML file. And you can see it's in great copy and pastable format. So we have all our variables our independent variables going down the left column here, and if I scroll down, it goes down to employment, so it doesn't include all those year and state fixed effects and things. And then each column is a different outcome variable. So each column represents a separate regression model, and then you can quickly just look across and see how the unemployment rate is associated with each of those outcome variables, and how age is, and how other things are. Okay. So that's outreg, the outreg file. Let's not save that. Okay, now we can, like I said, I'm not going to go through each of these different kinds of regression commands because they'll be similar, but we can run the entire analysis do file. Let's run that, and we can watch it run. And so again, you can feel free to use the structures that are in this analysis do file. You can iterate over loops. You can separate it out and not have loops, but just write each regression command out separately if that's what you prefer or what your instructor prefers. But I'm showing you this file, which I find to be a format which is easy for me to organize my analysis and produce results efficiently that I can quickly get into tables and that I can then use in written papers. So that's it. Just to recap, what you've seen today are 2 different kinds of Stata files with a lot of different Stata coding techniques, which I think you'll want to take your time stepping through and thinking about, and using pieces that you need for your project specifically. But this represents an entire empirical project that somebody might do in thesis, and is a basic, simplified, and heavily commented version of what somebody might do in a full research paper as well. Okay, so that's it. I hope you enjoy working with this tutorial on your project, and you should work with your instructors, with Christine and others for help with Stata. But I think this will get you off to a good start.